What we mean by classification is that we're breaking data from the attribute table into categories, and then we're coloring the map or shading the map associated with those various categories. In this example here, the category that we're using is the area or the size of each of these polygons, so that we can see that all of the smallest polygons are colored white, all of the medium-sized polygons are colored light gray, and only the largest polygons here are colored a dark gray. So we're basically just broken the size of the polygons into 3 different categories. All of them have to fall in one of those 3 categories, and then we just apply colors to the map based on those 3 categories. So an easy way to do this would just be, let's just say we only have 2 categories, a 0 and a 1, or one column in the attribute table that has 2 values, 0 or 1. And so in this example here, we're just going to put a value in the attribute table which says whether a state is to the west or whether a state is to the eastern United States. And we can see on the map here, everything on one side of the Mississippi River has gotten a 1 because it's west of the Mississippi, and all the other states have gotten a 0 here. If we wanted to, we could then put a color on the map so that 0 is one color and 1 is another color, just to reinforce the value we're already able to see just by putting those numbers in each state in this example here. If we only have 3 categories, we just need 3 shades of gray. And if those are distinct numbers and each one of the values in the attribute table is one of those 3 numbers, it's all very simple. So in this case here, everything that has a value of 1 is colored light gray, everything that has a value of 2 is colored white, and everything with a value of 3 is colored dark gray. However, once we start getting into maps like this, we have a whole bunch of polygons now. Now we have over 1,000 polygons, and this is the population for neighborhoods where the range could be as low as 0 and could be as high as 5,133. We could just start applying colors to the map, but we could also look at that data as something called a histogram, which is basically just what the value is of population on this axis here on the x-axis, and then how many times that value of population shows up on this axis here. So in this example here, they mentioned that between 3,000 people and 3,100 people, we would have 8 different polygons on this map that are associated with this one bar here. And we would have only 2 different polygons that were associated with this low population here. So now we can look at the histogram or the distribution of our data, and we can just decide where we want to put those breaks in order to make some of them white, some of them medium gray, some of them dark gray. How we do this is completely up to us, and we can pretty much make maps look any way we want to just by varying where we put those breaks in between where the white polygons are, where the gray polygons are, and where the black polygons are. So in this example here, this is from the book How to Lie with Maps by Marc Monmonier, a really famous cartography text, and it's showing us how that can happen. So depending on where we put those breaks in, here you can see there's differences here, right, between these categories. This shows where housing units lacking a telephone is below 10%, and there's only 1 state that's like that. But if we change that to below 20%, now look at all the states that are like that. And you can also see these 2 categories have changed as well. This goes from 10 to 15, now it goes from 20 to 30, and this used to be above 15, now it's above 30. We might use this map if we wanted to convince people back in 1960 no one had a telephone, and we might want to use this map if we wanted to convince people that back in 1960 a lot of people had telephones in the northeastern United States. Both of those maps are using the same data. They're just classified, and colors are applied based on that classification in 2 different ways. So how can we get the best possible map? Well, there is no best possible map, but we just we do the best we can. So one way to do it is just break it into categories and see how the map looks. But some strategies include the equal interval classification, and this is probably the simplest one to understand. So if the entire range is from 0 to 5,133, we just divide that 5133 by the number 3, and we can see that each of those categories or equal steps here would be about 1,711 population units. So the first category goes from 0 to here, which would be 1/3 of our entire interval. The second category goes to here, and you can see they've kind of placed a break in here. It goes from 3,000. We're missing 4,000, but this would be the third category here. We've just taken our histogram and we've broke it into 3 equal intervals based on the x-axis here of what the population is. So that would be an equal interval classification. And as we can see here, there's not much black at all on this map with the equal interval classification, and there's a whole lot of white because the highest portion of our histogram is in those low population areas here. So that may not be the best one we want to use. Another strategy is to use an equal area classification. And this equal area classification doesn't look to the histogram to make these changes, but it looks at how much area on the map is being colored with each of those 3 different categories. So what we can see here is if we added up the total area of all of the black areas that are colored on this map, it would be the same as all the gray areas that are colored on this map, which would also be the same as all the white areas colored on this map, which is where the area and equal area comes from. So we're being driven by the map distribution this time, as opposed to what the histogram looks like, and just trying to chunk out the histogram into 3 equal parts. Probably the most common way that we classify data, though, is by this natural breaks. And this natural breaks doesn't just look at the map, it does look at the histogram, and it looks for where these natural breaks are between where the distribution is either falling off or ramping up again. And we can see in this example here, we kind of have one category that is kind of this, centered on this high here. We have another category centered on this high here, and we have a third category centered on this kind of bumpy high over in this area here. This does not try to be equal interval. This does not try to be equal area. It's just looking at the histogram, looking for those natural breaks, and then dividing the classes, the classification or the categories into ones which represent these natural breaks.